A short answer, second ची answer key. First question, explain the reflection of light. हॅलो फ्रेंड्स, कशा आहात? आज आपण महाराष्ट्र शासन शालेय शिक्षण व क्रीडा विभागाने जी 2023मध्ये क्वेश्चन बँक फिजिक्सच्या विषयाची पाठवली होती त्याच्या आज आपण आन्सर की बघणार आहोत. आज आपण शॉर्ट आन्सर सेकंडची आन्सर की बघणार आहोत. चला तर मग शॉर्ट आन्सर सेकंडकडे जाऊयात. हे आहेत शॉर्ट आन्सर सेकंड. याची आन्सर आपण पुढील प्रमाणे PDF स्वरूपात पाहूयात. आहे शॉर्ट आन्सर सेकंडची आन्सर की. फर्स्ट क्वेश्चन, explain the reflection of light at a plane surface with the help of a neat ray diagram. आन्सर आहे reflection of light XY plane reflecting surface, AB plane wavefront, RBI reflecting wavefront, A1M B1N is normal to the plane. Angle A1 A1 M is equal to angle B. B1N is equal to angle I. Angle is the incident angle of incidence into bracket T. A1 M is equal to angle QB1 N is equal to angle R. Angle of reflection. Explanation. A plane wavefront AB is advancing obliquely toward plane reflecting surface XY. A1 and B1 are incident ray. Second, when a reaches XY at A1, then the ray at B reaches point P and it has to cover distance PB1 to reaches the reflecting surface XY. Third, let T be the time required to cover distance PBI. During this time interval, secondary wavelets are emitted from A1 and will be spread over a hemisphere of radius A1 R in the same medium. Distance covered by the secondary wavelet to reaches from 1 to R in time t is same as the distance covered by a primary wavefront to reach from P to B1. Thus A1R is equal to P, B1 is equal to CT. Fourth, all other ray between A1 and B1 will reach XY after A1 and before B1. Hence, they will also emit a secondary wavelet of decreasing radii. 5. The surface touching all such hemisphere is RB1, which is reflected wavefront bounded by reflected ray A1R and B1Q. 6. Draw A1M perpendicular XY and B1N perpendicular XY. Thus, angle of incidence is into angle A1M is equal to angle B1N is equal to I, and angle of reflection into bracket angle M A1R is equal to angle NB1Q is equal to R. Therefore, angle RA1B1 is equal to 19 minus R, and angle PB1A1 is equal to 19 minus I. 6. In triangle B1 RB1 and triangle A1 PB1, angle A1 RB1 is approximately equal to angle A1 PB1. A1 R is equal to PB1 into bracket reflected wave travel equal distance in the same medium in equal time. A1 B1 is equal to A1 B1 Therefore, triangle A1RB1 approximately equal to triangle A1PB1. Therefore, angle RA1B1 is equal to angle PB1A1. Therefore, 90 minus R is equal to 90 minus I. Therefore, I is equal to R. 8. Also from the figure, it is clear that incident ray, reflected ray, and normal lie in the same plane. 9. Assuming ray A1, B1 to be coming from extremities of the object A1, B1 in the size of object, distance between corresponding reflected ray A1T and B1Q will be same as A1, B1 as as they are corresponding part of the congruent triangles. This implies size of object in reflected image in same as actual size of object. Then also the taking A and B to be right and left side of the object respectively after reflection of light side at A seen at T and left side at B is seen at Q. This is explanation of lateral inversion. Question number second. Describe Young's double slide experiment with a neat diagram showing the point of maximum and minimum intensity. Answer. First, Young double slide interference of experiments of plane wavefront is made to fall on a epic screen AB having two similar narrow slide S1 and S2. Second, figure below show a cross section of experimental setup and the slides have their length perpendicular to plane of the paper. Young double slide experiment diagram आहे. Third, the slides are about 2-4 mm apart of each other. Fourth, an absorbing screen PQ is placed behind of AB. 5. Assuming that the slides S1 and S2 is equidistant from the S, the wavefront starting from S and reaching the S and S2 at every instant of time are in phase. 6. When the ray fall on S1 and S2, the two slides act as a secondary source of light, emitting cylindrical wavelet into bracket with the axis of along the slide length to the right of AB. 7th, the two secondary source emit waves in phase with each other. 8. The crest oblique throat of secondary wavelets superpose as shown in the figure of interference constructively high intensity, giving rise to bright band. 9th, when the crest of one wave coincides with through of other, causing zero intensity dark image of a slide are produced on the screen PQ. 10th, the dark and bright region are called fringe and the whole pattern is called as interference pattern. Question number 3. Explain the experimental setup for a diffraction with neat diagram. Answer. First, setup of for diffraction has a monochromatic source of light as out of the force of converging lens, ignoring aberrations. The emergency beam will consist of plane parallel ray resulting in plane wavefront. Second, These are the incidents on the diffracting elements such as a slide, a circular aperture, a double slit, a grating, etc. Third, in case of circular aperture, as is a point source of and the lens are b convex of linear element like the slide, grating, etc. The source in linear lens, the lanes are cylindrical in shape so that the focus image is called as linear setup of forever diffraction. Fourth, emergency beam is considered incident on other converting lens that focus the beam on the screen. Question number 4. The distance between two bright rings in bispheral experiment using light wavelength 6000 AU 0.32 mm by how much will the distance change if light of wavelength 4800 AU is used? Use solution. Given the distance between consecutive bright rings y is equal to 0.32 mm is equal to 0.32 into 10 raised to minus 3 m. Lambda is equal to 6000 AU is equal to 6 into 10 raised to minus 7 m. Lambda b is equal to 4800 AU is equal to 4.8 into 10 raised to minus 7 m. Let lambda be the distance between the consecutive bright rings when the wavelength lambda b is used. To find change in distance between the rings into mod ya minus yb, formula ya into lambda b is equal to yb into lambda b. Calculation from formula. Therefore lambda yb is equal to lambda a divided by lambda b. Therefore lambda a is equal to 0.32 into 10 raised to minus 3 into 4.8 into 10 raised to minus 7 divided by 6 into 10 raised to minus 7 is equal to 0.256 into 10 raised to minus 3, and therefore change is equal to into mod y minus yb is equal to into mod 0.320 into 10 raised to 3 minus 0.256 into 10 raised to 3 mod complete is equal to 0.064 into 10 raised to minus 3 meter is equal to 0.064 millimeter. आन्सर वर्डमध्ये असल्यामुळे फेस केलेला आहे. वर्डमध्ये द चेंज इन इन्सिडेंट बिटवीन द फ्रिंग्स इज 0.064 mm. Question number 5. A parallel beam of green light wavelength 546 nm passing through a slide with 0.4 mm. The intensity pattern of the transmitted light is green on a screen which is 40 cm away, or distance between the two first order minima. Solution. Given lambda is equal to 546 nm is equal to 546 into 10 raised to minus 9 m. A is equal to 0.4 mm is equal to 0.4 into 10 raised to minus 3 m. D is equal to 40 centimeter is equal to 40 into 10 raised to minus 2 meter. To find distance between the two first order minima, formula. Width of central maxima WC is equal to 2 lambda d divided by a. Calculation from formula. WC is equal to 2 into 546 into 10 raised to minus 9 into 4 t into 10 raised to minus 2 divided by 0.4 into 10 raised to minus 3 is equal to 2 into 4 5 6 into 10 raised to minus 6 is equal to 1092 into 10 raised to minus 6 is equal to 1.092 into 10 raised to minus 3 meter, approximately 1.1 mm. The distance between two first order minima is equal to width of central maxima is equal to 1.1 mm. आन्सर वर्डमध्ये असल्यामुळे फ्रेम केला आहे वर्डमध्ये. डिस्टन्स बिटवीन टू फर्स्ट ऑर्डर मिनिमा इज 1.1 mm. Question number 6. In a forever diffraction by the narrow slide, a screen is placed at a distance of 2 meters from the lens. Obtain the diffraction pattern if slide width is 0.2 mm and the first minima is 5 mm on either side of the central maxima. Find the wavelength of all light. Solution. Given d is equal to 2 m, a is equal to 0.2 mm and 2 into 10 raised to minus 4 m, y id is equal to 5 mm. Width of the central maxima is equal to 2y id is equal to 2 into 5 mm is equal to 10 mm is equal to 10 into 10 raised to minus 3 meter. To find wavelength of light lambda. Formula. Width of the central maxima wc is equal to 2y lambda d divided by a. Calculation from formula. 10 into 10 raised to minus 3 is equal to 2 into lambda into 2 divided by 2 into 10 raised to minus 4. Therefore lambda is equal to 10 into 10 raised to minus 3 into 2 into 10 raised to minus 4 divided by 2 into 2 is equal to 5 into 10 raised to minus 7 meter is equal to 5,000 a. आन्सर वर्डमध्ये असल्यामुळे फ्रेम केलं आहे वर्डमध्ये. वेवलेंथ ऑफ अ लाईट इज यूज इन 5,000 a. इथे आपले सर्व शॉर्ट आन्सर सेकंड संपलेले आहेत. व्हिडिओ आवडला असेल तर लाईक करा, शेअर करा, सबस्क्राईब करा आणि बेल आयकन दाबायला विसरू नका, कारण नवीन अपडेट आपल्या चॅनलवरती तुम्हाला मिळत राहतील. धन्यवाद.